The purpose of this video is to learn how to draw graphs correctly. So for demonstration, we have some example data here in a table. This is a table of temperature over time, and as you can see, we've got two columns which should be completed. Let's say that time is measured in minutes and temperature is measured in degrees Celsius. Now keep in mind that this table, which I call a total table, can be drawn differently. So on this side over here, I'll draw the same data but as a horizontal table. So I'll put time first and temperature here, and then have the data, so 0, 1, 2, 4, 6.5 and 25, 36, 51, 80 and 105. So just realize that these two tables are showing identical information. Okay, the fact that this is drawn like this and that's drawn like that doesn't matter. Both tables are correct. Admittedly, I have not drawn this very well, but they show the same data and both are quite valid to use in your investigations. Now, one of the first goals that you'll learn with this demonstration is that in a properly drawn table, whether this way or this way, always we have the dependent and independent variables in certain locations. So I'm going to use, for my colors here, I'm going to use green for my independent variable, and I'm going to use my pink for my dependent variable. Now keep in mind, when you go about working which one's which, always the dependent variable are the things that are measured. Okay, that's what your investigation is all about, measuring these particular values. Now this one over here is the thing that you are changing. Okay, so provided that tables are drawn correctly, and they are, I'm going to highlight the two variables, and in this table, if it's drawn this way, the independent is always on the left hand side. So this is my independent variable, all of that there. And the same way, in this table going horizontally of the same data, the independent is on top instead. And likewise, the dependent is anything right of the independent. So this is my dependent variable here. There could be more columns. They would all be dependent variables. And the same thing over here. My dependent variable is this one over here. Alright, so rule number 1. In tables, the independent is left or top, and your dependent is right or bottom. Alright, so hopefully that's all quite clear in the video so far. Now let's go and plot this data, okay, and work out what kind of graph it will be, whether it's going to be a line graph or a column graph. So another rule is when we go about drawing the graphs, the axes are done this way. So this is the horizontal here, and this is the vertical here. So what we're going to do is we always plot the dependent over here and the independent on the horizontal. Okay, so dependent is plotted on the vertical and independent is on the horizontal. Okay, now let's go about plotting this graph now and see how it looks like, making sure it's done correctly. Okay, so here's my data. Let's focus on this table here, and I'm going to plot this. So
can I have purple?
I'm using this right now. Just wait.
I want purple.
Okay, just wait. Let me finish up, please. Okay, so remember that with a graph, we always plot the independent on the horizontal axis, which means time goes down the bottom. I put time down here. Time is measured in this case minutes. And now for my time, I'm going to draw my tick marks on the grid lines. Okay, now deliberately we're using these red purple now. We'll use a pencil to show you the wrong way and the right way of plotting the data points here. So we got, for time, we got 0, 1, 2, 4, 6 and 6.5. So you do not do it this way. This is definitely incorrect, because what we're doing here, we're changing the interval from there to there. So here it's 1, a spacing of 1. That's okay, that's 1, 2, but here it becomes 2, and then from there to there it's 2.5. So it's all over the place. So that is the wrong way of doing it. Now the right way of doing it is this. We maintain an interval, say for this example, of 1. My pencil broke. So 0 to 1, 1 to 2, 2 to 3 goes over here, 3 to 4, 4 to 5, and extend this on further. That is 6, and hopefully that's all in the view. Great. And likewise for on this axis, which is the dependent variable, I plot temperature. And I'll start off over here, and I'll go by, I need to make sure I fit all my data in my spacing here, so I might go by 20s, so starting for 0, and likewise the same as before, I don't go 0, 25, 36, 51, 80, 103, no, I maintain a fixed interval, so I'll go it by 20s. And of course that should be extended a bit more. And now the next thing to decide is what kind of graph. So rule number 3 is we need to look at the data in the independent variable. Okay, now we look at the values here and we see that we have a sequence of numbers, in this case time, every minute or so. Now there have been some times during the experiment here where they have not measured at a regular interval, so they missed out at 3 minutes, they missed out at 5 minutes, and they measured at 6.5 minutes instead of 6 minutes. But that's okay, that can happen. It's still a legitimate measurement even though it's not done regularly. And because this is a sequence and the order is important, we need to make sure that 1 follows 0, 2 follows 1, 4 follows 2, and 6.5 goes after 4. We don't want to change the order of any of these values, so that what I mean is I don't want to put 4 in front of 2 and 2 in front of 1 on my axis here, because that would not make sense. So we want to maintain the sequence. So when we have our independent variable data in a sequence and the order is important to be maintained in this going from minimal to maximal, that's when we decide we draw a line graph. Now when this data here is not in a sequence, or the order does not matter, then we draw a column graph. But this is a sequence. Even though it's a funny looking sequence, it's still a sequence and the order is important. We need to make sure that's last and that's first. So now I've decided on a line graph and I'll start plotting the points. So 0, 25, 0, time at 25 degrees, there's 30, there's 25 there, and then let me just check the view. Good. 1 minute at 36, which is about here, 2 minutes at 51, which is about here, 4 minutes over here at 80, and 6.5 minutes, which is over here, not very drawn quickly, I admit. That's a 103, which is about there. And now I connect the dots. Okay, it should be with a straight line, but you get the picture. And don't forget that every graph should have a title, and in the absence of any meaningful thought about it, I could just simply use temperature versus time, but I might just make this more meaningful and say temperature during experiment. And that's pretty much a rundown. So I'll do this again with another set of data, and let's see another way of drawing a graph depending on what data type you have. Now here's another set of data. Let's turn this table into a graph, and as I said before, this table can be drawn horizontally like this or vertically. It would be the same information and both tables would be valid. Now same as before, in this thing here, the data which is measured is going to be the counts. That is our dependent variable, and the data which is we're comparing, which has changed, are the animals, which I do in green. So as before, whenever you draw a graph, you have the dependent variable on the vertical axis and the independent variable plotted on the horizontal axis. So for this one here, I'll start drawing my axes now. Okay, so hopefully that's on the view. Yeah, alright. Alright, so my dependent variable is counts, so I'll put it over here. and my independent variable is the animal down here. Alright, so now the big question now is, what kind of graph will this be? So again, I look at the independent variable, which is the one in green. Okay, and the big question to ask now is the sequence of names here important? Do I need to maintain this sequence? Is there an order to this? Now there could be an alphabetical order, that's okay, but really whether it's alphabetical or not, does the sequence of names need to be in any particular order? And the answer to that is no, it doesn't matter. So when we have decided that the order of these values doesn't matter, that's when we decide we're going to draw a column graph. And here in science we like to be fussy about drawing column graphs. We like to put our columns with a gap between them. So now I'm going to choose any of these values here, let's say wallabies, and I'll put the wallaby in the middle here, and I draw, and I'm going to work out my values. So keeping equal intervals, so let's go up by 50s, so 50, 100, 150, 200 and 250, right? So wallabies 11, so there's somewhere down here, about there. So I've done wallabies, forget that now. That's eagles, I'll go eagles next, so it doesn't really matter the order as I said before, so therefore I can choose any of these next, doesn't matter. It could be lizards, frogs, eagles, I chose eagles, and that column will go up to here somewhere. And then lizards, we've got 59 there, so plot this about there. And then frogs, 252, so up here. And of course, if you're doing this yourself, you draw with nice straight lines. And lastly, quokkas, and that has a count of 3 down here somewhere. So as you can see, I've drawn my graph with the columns because the order of these values doesn't matter. I could put that one first or this one first, it doesn't matter. And I've got gaps between my columns, which I should really draw with a straight line, but for time's sake I'm just not bothering with that. And don't forget, every title should have a graph at the top there. So this could be populations of various animals. And of course you would do this a lot neater. So there we have it. We have a table and graph drawn correctly. Not very neatly, but I followed the rules of how to draw a graph correctly. So remember, make sure your tables are drawn correctly with your independent variable on the left or the top. Your dependent variable is on the right. There could be more than one independent variable, or the bottom. When you draw your graph, your dependent variable is on the vertical column, your independent variable is on the horizontal column axis here, sorry, and you make the right decision about whether it's going to be a line graph or column graph. So if the data in the independent variable is in the sequence, we draw a line graph. If the data in the independent variable is not in a sequence, or the sequence is not important, we draw a column graph. So if you have any questions, come and see me in class or find me online. All the best.